Hi, everyone. How's the audio? Good? So I cover big data and predictive analytics for Forrester. Enormously hot topic. I mean, that's why we're all here, right? Last week, I looked at Forrester's web stats about our clients and what are the keywords they're searching on. Guess what number one was?
Big data.
No, it wasn't big data. It wasn't Hadoop. It wasn't analytics. It was mobile. Mobile was the number one search term, but it was on the decline by 6%. You know what number two was? Big data. And it was rising 24%. So, so there's definitely a great interest from our clients who are mostly large enterprises, you know, the largest enterprises in the world, but also vendors. So I field inquiries from both sides constantly. I'll have days of 11 back-to-back half-hour calls. It's insane. So there's a lot of demand for trying to understand what this is. Now, you may be wondering why I cover this, okay? Because this hasn't been hot. Did I just like pick up on this? It's because I'm a failed data scientist. Now, when I was 22 years old, I just graduated from college, and I had this great idea, me and my professor. So we started a company. And I got my pilot's license when I was 17. I just, you know, I loved flying and stuff. So we said, remember AI in the 80s, artificial intelligence? That's what we're talking about here, sort of, machine learning and stuff. Well, we said, we can create an AI system that will automatically control air traffic. It could replace an air traffic controller. Remember Reagan fired a few guys and, you know. So the FAA funded us. Can you imagine that? They funded us to actually use AI. Well, anyway, let me shorten this story. So what we thought is well, let's get all of the data of every plane that flew into Boston and New York. We focused on those two air traffic control centers. And let's look at the instructions that the controllers gave. And then let's use machine learning algorithms to create a predictive model when you should tell a plane to descend and turn. Isn't that insane that we actually tried to do that? It may actually end up happening someday when I hear about what Google's doing with the cars. Anyway, we failed. Okay, we didn't have enough data. We didn't have enough compute power. We probably didn't know what we were doing. Now, there is a silver lining, though. We did use rules-based expert systems, and we got 3 patents. So anyway, because of that experience, I was assigned to cover this area, and I love it. So I'm going to talk to you about some of the trends that we're seeing shaping big data in the enterprise specifically. You can see here that when we survey people, there's definitely a momentum here. You can see that 37% are planning some big data technology project. Many are interested and have no plans. So it is a hot topic. Now, I disagree with the prior speakers that says everyone defines big data differently. This is the definition. Okay? So our definition, and I can break this down, but it would take 30 minutes. We say it's the frontier of a firm's ability to do 3 key activities: store, process, and access all of the data it needs. And then we link it to sort of the business objectives. Okay, the 3 V's, volume, velocity, and variety, those are measures of big data. Very interesting, but not a definition. So that's our definition. I hope you're with me on this. Okay, plus it's got a little acronym SPA. Anyway, trend number 1 is big data itself. Okay, and one of the things that we've noticed is a shift that big data is increasingly means all of your data. Okay, it's not just social data. Right? People were thinking, well, it's not just data in Hadoop. It's all of the firm's data. And one of the key questions that enterprises are asking is they want to break down these silos. They want all that data together. They don't want to just look at Omniture data on their web logs and have CRM data over here and have transactional data over here. They want it all together. So increasingly, this is how enterprises are thinking about big data. Not just about one data silo, but about all of their data. I use the metaphor of a coral reef This is the Indian Ocean. If you take any 100 cubic yards of water there, you might find 12 fish. If you take the same amount of data, this is where Charles Darwin, that was his first scientific discovery on the Keeling Islands. A coral reef has this millions of species, okay? And this is what companies have to do, is get their data together. Now, big data is also all your data. We don't just say structured, unstructured, semi-structured. It's structured text described by a schema. It's unstructured text, but it's also binary. I mean, I think we all know that it also includes binary, but we don't talk about binary very often. We don't talk about facial recognition or image analysis and stuff like that. So it's really important to think about binary as well in this whole field. We ask questions. Sorry about the semi-structured. It's how we ask the question. We didn't ask about binary. But when we polled business intelligence professionals, in this case, they're saying, all right, we have all this data. We're only using 12% of it now for analytics. So people aren't using as much data as they have. And then when you ask companies, why? Why big data? Why are you interested in it? It's about their entire data universe. And I think if you look at the bottom red, there's also a motivation that the earlier technology is too expensive. I disagree with that. I think there's a confusion about, in particular, what Hadoop can and cannot do. I don't think it's a replacement for enterprise data warehouses, at least in the short term. Now, I said it's all your data and more. The other top question that I get asked is, how do we pull in all these other data sources? I mean, financial firms have been pulling in external data sources for years, from Experian and other providers. But they increasingly want to make use of public data sets. One company I encountered is a startup called One Ocean. It's data about the ocean, waves, temperatures, that shipping companies can use to save millions of dollars by understanding the currents and the temperatures and the flow of traffic. At Amazon Web Services, you can get all of the Enron email, where they have 1 million emails. You can just download that for free and do text analytics, and I don't know what you're going to find. We already know what happened. But there's an increasingly amount of public data sources, and there's a bunch of startups starting to aggregate and pull this together so that companies can use it. Now, this is disappointing, but not unusual. When we ask people what is the key inhibitor, managing and integrating data from a variety of sources. And I think someone on the last panel said something about that. That's one of the key challenges of Hadoop, too, getting all that data together and mediating it, and doing ETL and processing it. Quality as well. So this is still a very key issue and key challenge. You can see finding the right kind of analytical talent appears on the list as well. So when we get back to the definition, if the highest level taxonomy, you have to think about these three things. Store, you need to be able to store the data, capture it, and store it. So some of these streaming vendors, but also storage, traditional Hadoop, you have to be able to process it, cleanse, enrich it, analyze it, run algorithms, and then also access it, visualize it. So when we talk to a company about their strategy, their big data strategy, we talk about these three things, and there's many categories beneath them, as you can imagine. Big data is not about one tool or technology. I think we've heard that universally today. And this is, I don't know, this is sort of a crazy diagram that we came up with to kind of show firms in the gray sort of what they have now, or largely what they have now, and then in the blue, some of the new technologies, some not so new, but the technologies that they have to do to support big data and predictive analytics. So when we think about that trend, when it means all your data and more, what does that mean to business? I mean, businesses definitely want to get all that data together so they can analyze it together. And the recommendation we make to businesses, don't do what you normally do to IT. Don't go to IT and say, oh, yeah, we need all this, we didn't know this. Just insist, because otherwise it's not going to happen, okay? And for IT, they can't just think about Hadoop. They have to think about this whole big data analytics platform, they have to think about all these storage. If all they do is they go out and buy Hadoop, and we recommend that they do need Hadoop. You saw that in the prior slide. But it's not the only consideration. You have to be able to process it. You need predictive analytics software. And the other key issue is they have to loosen data governance. They want to control. A data scientist doesn't go to you and say, I need these 10 fields, or I need these 100 data elements. The data scientist says, I don't know what the heck I need. Give it all to me. Okay? And IT's not used to hearing that. Okay? So they've got to wise up to that. For investors, when we talk to startups and companies, we see them looking at, they get it, they're looking at these full range of companies, and they're looking for those indispensable components in that big analytics architecture. Second trend is predictive. You know, big data has definitely gone from, wow, there's massive amounts of data out there. It's definitely gone from that to, what the heck can we do with this? What can we find it? And that's all about predictive analytics. And you know, the way I think about this trend is I call it the algorithm wars will begin. Okay, and we heard from the last panel, we heard from Pandora, we heard from Kaggle about algorithms and the importance of algorithms, because those are, I call them robot armies, right? Because the algorithms are the things that scour through the data and do all the work. So we're seeing firms now wise up to this, and the firms that already understand this, they closely hold those algorithms close, but others are wising up to that. So predictive analytics can discover non-obvious information you don't know, but it can also create predictive models, risk scoring, all the examples you already know about, song lists like Pandora. And that is all about probabilities. Oftentimes people get confused with predictive and they think that's impossible. How can anyone predict the future? And predictive isn't about that. It's about a probability. It's about a 67% chance that this user will click on something. And that's important to understand. Data science is very different from business intelligence. In business intelligence, companies, they choose a business outcome to improve. You do that on the data science side too. But in BI, you decide. You kind of get in a meeting, or you kind of decide what you think is relevant, and then you go and create a data model and create reports based on that. In data science, you unleash that robot army to go find the answer. And in that way, could data science actually be easier than BI? I don't know. That's something I've been thinking about for a while. So this is how I look at it. A BI analyst is sort of a farmer, just, you know, farming the crops, going out there. A statistician slices and dices. These are the tools they use. And the data science, he's a robot master. He's unleashing his algorithms on that data to find the meaning. And you know, these are just, data scientists will know these algorithms, or if you're a computer science major, or if you did machine learning or AI or statistics, you recognize some of these algorithms. There are hundreds of these things. There's hundreds of these things, and that's where a lot of the genius, not the only genius, but that's where a lot of the genius of a data scientist comes in. I disagree with the people who say that a data scientist is someone who knows sort of the technicalities of Hadoop. Certainly it's great if you had a data scientist that was technical and understood scientific method and understood these algorithms. That would be great. But this is essential. Understanding this is essential to data science. And we heard earlier about some examples about Watson, and I'm not going to, you know the example, okay? But the key point here is that the future of predictive analytics isn't one algorithm, it's ensembles of algorithms. Okay, Watson wasn't one massive algorithm and predictive model, it was many put together. People who won the Netflix prize had an ensemble model. And so now this multiplies the complexity. It's not just about running one of those algorithms, it's about putting many of those together. So this is a big trend in predictive analytics, especially for the most competitive use cases. And we heard about data competitions. And this is sort of a public algorithmic war battlefield. And so that's very interesting as well. Now, for businesses, they have to, when they think big data, they have to think about predictive analytics. They have to think about their business processes and how predictive can help in those business processes. They need a new budget item, data research. Because if they're going to ask what the ROI is, if they're going to ask, can you guarantee an outcome, the answer is no. Okay, so they're going to have to think of data science, and they're going to have to think of that part of big data as research that's going to have to be funded. And we know that in research, there's no guarantee of a result. So businesses are going to have to ante up to do that. And the evidence is that they're very willing to do this. For IT, we tend to think about the storage, but all these algorithms are very compute hungry as well. So they're going to have to implement Hadoop with MapReduce, enterprise data warehouses, look for cloud solutions. They're going to have to look to build that ecosystem. And for investors, when it comes to predictive analytics, algorithms can be the secret sauce. Does anyone know of a company called Bloomreach? You know Bloomreach. It's one of many, but it's a SaaS-based offering. You stick a pixel on your e-commerce site. One of their clients is Williams-Sonoma and Neiman Marcus. And they take the traffic in, and they try to determine the person's intent based upon what they know about them, based upon the search terms they came to the site. And then they add content in there to help convert them even more so with enormous success. So we see a lot of companies popping up like that, which will have a very algorithmic secret sauce that they'll use. So the third trend of 4 is data science, and we just talked about data science as predictive analytics, but this is a very different trend, and we've heard it before in some of the panels, and that's about the democratization of data scientists. I suggested to you a little bit earlier that maybe data science is easier than BI. And I know that's crazy on one level, but there's some truth to it as well. So we're seeing the traditional data science in the lab coat, and this is going to go right down to business people on the one hand, but then programmers who have the engineering and have the math background who are going to learn about machine learning and these algorithms. Isn't there a course, one of those online courses, machine learning, Coursera, 100,000 people have taken that course, obviously technical people. So here's sort of the data science discovery lifecycle. First you have to understand your data and where all the sources, and that's why you have to get it all together. Prepping the data. Prepping the data, most data scientists will tell you that's 70% of their time is putting that together. I talked to a data scientist at one of the Blue Cross Blue Shields, and he was a statistical master's in statistics. He told me he wrote hundreds of lines of SQL, just taking data out of data warehouses and other sources, just to get the data ready to then run. And his contest was it wasn't a contest, but what he was trying to do is create a predictive model to prevent rehospitalization. Once you have that data, then you have to figure out what algorithms do I run against it, and that's the modeling phase. And that's a very iterative process, right? And then when you go around this entire life cycle, this is what takes time, okay? So to democratize this life cycle, you need sets of tools that make it easier for business people and other people to do it. It's not going to replace data scientists. All right, I mean, the Java thing, right? All I was trying to say is that if you're going to write a report, an enterprise report, you're not going to write that in Java, right? You're going to use business objects, or you're going to use Cognos or something. But that doesn't mean you don't need Java. And the same is true for this emerging data science. How many R programmers are there out here? Okay, there's a lot of R programmers. Forgive me for saying this. That's a nightmare for a business person, right? I mean, it's a technical programming language. You'd all agree to that, right? So someone's not just going to pick that up. R has a place, just as data scientists will have a place, but there's a huge opportunity for business people to use this too. Now, one of the research pieces I recently published in January 3rd was a Forrester wave, and we evaluated 10 platforms, we call it big data predictive analytics solutions. And these are software that sort of address that full life cycle. And I won't go into the details of this because I don't have time. But you can see some of the leaders in this wave were SAS, SAS Institute, who's been in this thing since 1973 with their Enterprise Miner product. That's one of those tools. But even at that, it was still designed for data scientists. But what all these vendors are doing, well, not all of them, but most of these vendors are doing, are trying to create that tool or a new set of tools that will let business people use it, just like report writing tools or business intelligence tools let a wider number of people use it. Now, just because you see some of these, like Revolution is out there and Salford is down there, they all have, some of these are niche players. And the leaders, at least the way we evaluated it in our 60 criteria, all had sort of very broad, full solutions. And we also see that some of the players that have been in this for a long time can't handle big data sets. Nor do they need to most of the time, but most of them haven't tackled that issue yet. So the key is to compress this life cycle, both for data scientists and both for business people. And that's going to be focusing on getting the data prep, making that easier, and integrating it. And then this idea that you can do auto modeling. Now, remember that list of algorithms? Well, you kind of pick one, you see if it works. Oh, that didn't work. Maybe I'll try a tree net. Maybe that'll make it better. Oh, nothing's working. Let me see if I can add some more data. And then you kind of iterate on that. What some companies are doing, because they have the compute power, they're just saying, run them all. Run 20 algorithms against it, and then show me the lift. Or show me, evaluate them against the training. So auto discovery, this notion of auto discovery is why I think in some sense this could actually be easier in some cases than business intelligence, where you have to still make a lot of decisions. Now, when I evaluated those companies, was the Million Song Dataset in Kaggle? Does anyone know? I think it was. It was a public data source. So all of those 10 vendors, I had criteria. There were lots of criteria, but one of the things we did is we did a lab. And I asked them all to download this Million Song Dataset. And it's not that huge, right? It's got 48 million songs listened by 1.2 million users. And I said, come in, I'll give you 1 hour to create a predictive model with your tool, okay? And the only pre-work you can do is to download these data sets and have them ready. It was so much fun to see them. And every single one of them, I felt like I could do it, and a lot of people could do it. But they all had very different solutions. The one here is this company called KXEN, which used social network analysis. They actually did it that day. They submitted it the same day, and they immediately appeared as number 6 on the leaderboard, which is quite amazing, because most of the time you have to submit to get on the leaderboard. But if any of you are actually going to evaluate any of these products, I suggest you do the same thing. Pick a data set that's out there and say, show me. And it will really give you a great feel for these tools. We think that from a business standpoint, thinking predictive in all your business processes and customer experience will become a norm. Where can we use predictive modeling to improve our business? We know some businesses this already occurs. And we think in the democratization of the apps, there's companies like Alteryx who are building app stores, or Alpine Data Systems, which I think was mentioned, where people can build these little analytical apps that can then be exposed to business users to use them, similar to the way reports are exposed. IT, again, has to loosen up on the data governance, and they have to have better tools to use this, and they have to have elastic sandboxes. You can't say, oh, we don't have enough storage, we don't have enough space, and this is where cluster-based storage like Hadoop is tremendous, because you can just keep adding it and grow and shrink it as you need it. And I think we already heard from the investor panel that they think there's a big opportunity in this democratization of these tools. We heard that in the panel. Now, the final one is the ability of predictive, big data and predictive analytics to actually disrupt for large firms to become a digital disruptor. So I call these predictive apps, okay? And predictive apps are when you start trying to fuse predictive models in the apps that people use, either on their tablets or their mobile devices or in embedded devices in their lives. And here, when we ask companies what's most important to them to now, you know what it was like 3 years ago? Do more with less. Do more with, you know, you survey business executives, it's like, we need to do more with less. Now you know what their number one thing is? Innovation. Innovation and customer experience, okay? And this survey drills down even more. People want to be treated like individuals. Because we all want to be kings. And so this is the trend driving it, and this is where predictive analytics can help. There's 4 distinguishing principles between a regular app and a predictive app. Number 1, you have to learn about the customer. Do you guys know about personas? Personas and segmentation, that's sort of the conventional way. You know, instead of designing for one user, you create maybe 4 and you have characteristics and then you design an experience for them. Well, that's still aggregating potentially millions of people down to like 4 segments. That's not how you get more individual. It's the starting point, but to get more individual, you have to learn more about you. Just like Pandora knows how to mix things in for me and make it very personal for me. Then you have to detect in the moment intent, like Google Now. Google Now is well, at first I thought it was creepy, but now I like it. I like this whole notion. But I got my new Nexus from Google I/O last year, and then I take the bus to work. And 2 weeks after taking the bus to work, all of a sudden it put up a card with the bus schedule. Whoa, it watched me, it followed me, and then it said, Mike, you take the bus, I'm going to help you out. Right? It learned about me, it detected in the moment when I was going to the bus stop, showed me when the next bus was going to arrive. Imagine what you could do in other apps, okay, and imagine how they could be combined. I've got a Nike Fuel, is this a Fuel Band? Yeah, I was going to say Fit, because I had a Fit too, but the Fuel Band. Imagine if I went on my run, imagine if I went to lunch at the Cheesecake Factory, took out my tablet, the menu is customized not only to my preferences, but it says, yes, you can have the cheesecake, okay? So you can imagine how all of these, how you could know about the individual, detect the in-the-moment intent right now, and then morph the functionality and content to match that, okay? That's a very different design paradigm. And then, of course, you have to optimize it for the device that they're on, because we know that, you know, increasingly people are on 3 devices. So we think predictive apps are the next form of digital disruption, okay? We've seen, you know, there was no individualization in apps, and then we had role-based or persona, which made it a lot better. And then we started thinking about the difference between web apps and mobile apps. And then we started talking about how they can be context-aware. Predictive means that they're you-aware. They're context and they're you-aware. And they'll provide these dazzling experiences. But to do that, we're gonna need to know more about the customer. And this is how it brings it back to big data. Okay, we need to infer their behaviors, their aspirations, their mood. And this is sort of the combination of why you need all the data together and why you need data science. Now, people might be saying, you know, we're out in California, so you don't care who knows what, right? But you go to Europe, you don't care about privacy, right? Do you? Okay, I'm from the East Coast. We don't care quite as much, but then I give this talk in Europe. Whoa, they're like, privacy. I mean, they've shut down slide number 1 when I put up big data. I would not be able to continue this presentation, okay, in Europe because of privacy. But it is a good point. As we gather more data about people and their locations and their GPS locations, and we grant them this, companies can't do creepy things with that data, and they have to respect the privacy. And this, of course, is, you know who this is? Yeah. So, and he is just perfect everything. And he's a butler. And that's what these predictive apps really become. They become sort of a digital butler in someone's life that sort of understands you. Businesses can use this whole notion of the predictive app to become disruptive in their competitive environment. And what that means is they have to intensify and individualize the user experiences. How can they do that? Big data, data science, it's happening now. There's many firms already doing it. IT has to be able to develop these predictive apps. They have to have a continual learning cycle. I don't know if they need a 200 cluster Hadoop like Pandora has with all those connections. It's likely that the companies will be selling enterprises similar capabilities. But they're going to have to expand their team. So if you have an enterprise IT development team that's developing apps, mobile apps, predictive apps, you need to hire 3 new people. You need a psychologist. You need to understand your users and individualize. You need a data scientist who can create these predictive models. And then you need a personal user experience designer, someone who can then take that information and design the experience. And for investors, this is sort of the logical conclusion of digital disruption, is to make these apps much, much more personal. So these were our trends. I think I'm just about on time. Big data is all your data. And these trends are coming from the research that we've done. Algorithms are key. An increasing number of people want to be able to do data science, and we see vendors creating the tools. And predictive apps are sort of one of the most disruptive forces that we're going to see, at least in the next step beyond mobile. Now, I did a blog post on big data predictions for 2013, and my last prediction, I got sort of laughed out of the analyst community, but I predict that big data will be the Time Person of the Year. It's entirely possible, right? I just published a blog post yesterday on Intro to Predictive Analytics reading list. I've got 4 great books, for anyone who wants to learn about those. And I don't know if we have time for questions, but I'll be circulating, so you can talk to me then. So thank you very much.